Yes. All right. Here we have number 1. Okay, so we're going to be listing the domains for each of these sets. Part A, it says find the domain for each function. List in interval notation if possible. That's important. Okay, we're going to talk about when that's possible and when that's not possible. All right, come on, keep up. All right, so my domain, remember, is all my x values. So part A, we actually did this one yesterday, right? All of my x values. So my domain would be 1, 2, 3. When we list domain in set notation, notice the difference. Set notation is not interval notation. Set notation, we list them in order, least to greatest, and we don't repeat any values. So if I had another, let's say I had 2, 6 in this set, I would only list my 2 once. Okay, so when we're in set notation, we don't repeat values, and we list them in least to greatest. Okay? All right, let's look at B. If I look at B here, remember one of my restrictions, what can I not divide by? 0. I can't divide by 0, right? So this denominator cannot equal 0. In other words, if I subtract 5 from both sides, x cannot equal -5. So if I were to say this in words, I would say x can be all real numbers except for -5. This is an example of one where we need interval notation. Okay? If I were to think of a number line, I could list everything except for that -5. Okay? It could be -4.9999. It could be -5.1, right? All of those would work. I just can't have -5. So if I were to write this as intervals, what would be my first interval from here to here? What would I list there? How would I say that? Yep, 2. -5. Okay? There'd be a break. Then what's my last interval? -5 to infinity. Okay?
Would -5
Not have a bracket because it's open. If I had a bracket, that would mean -5 is included. Okay? All right, any questions on that one? That's our first example of interval notation. All right, let's look up here. C can be kind of tricky. Because as we look at that, do I see any fractions or denominators I have to worry about? No. Do I see any even roots? No. So at glance, we're tempted to say all real numbers. However, we're talking about volume. Is it possible for a negative volume to exist? No. Okay, we cannot have a negative volume. Okay, if I draw a circle, even if it's the tiniest circle in the world, it's not going to have a negative. So if I'm thinking about R, because in this situation, R is my independent variable, that's what my domain values are going to be. What would the smallest possible radius be? Smallest possible one. What do we? Yeah, 0, right? We could have nothing at all. So R could be anything bigger than or equal to 0. Okay? So my domain, again, if you think about this as a number line, here's 0. R is going to be 0 or anything bigger than it. Oh. So as an interval, I would say 0 to infinity. That would be my domain. Okay. All right, my last one here. Okay, again, notice I have an even root here, so I know that what can I not have in the inside there? A negative number. So in other words, I don't want what's inside there to be less than 0. It's okay if it is 0, but I don't want it to be less than 0. That's what I'm trying to avoid. So let's figure out what x would have to be for me to break that rule. Oh, -4 both sides. Divide by -3. Now what happens whenever I divide by my -3? Yeah, the sign flips. So again, we think about it in terms of a number line. I've got an open circle there because it's not included. And then x is anything bigger than that. So my interval would be positive 4/3 to infinity. So just take a look at this for a second. See if you can notice a pattern here between when I use set notation and when I use interval notation. If you were to describe when to use either, what would you say? Yeah, Molly.
Use set notation as like a set of numbers.
Right. Whenever I give you a set, use a set. Okay? If I don't give you a set, if I give you a formula or an equation, that's probably when we're going to have intervals. Okay? The only time that wouldn't work is if my domain could only be one number. Okay? Could only be one number. That would be the only time that we'd only use set if we were given an equation. Any questions on these four? All right. Flip the paper over. Let's do some calculus. Difference quotients. Okay, so like I said, we're going to get more into the calculus piece of this tomorrow. But for today, we're going to learn this formula. This formula is basically the basis of calculus. Okay? Our difference quotient, also I'm going to make a little note here. You need to know this for your test. I'm not giving it to you. Okay? Need to know for the test. Okay, this is not a formula I'm going to provide because this is a big piece of pre-calc. Okay? So my formula, I'm going to try to use some colors here. We're going to do f of x plus h minus f of x over h. Okay, so right now that probably doesn't have much meaning to you, and that's okay. But that is our formula. F of x plus h minus f of x over h. And now we have to set a rule. So oftentimes we'll see this. We have to set a rule here. What can h not be for me to work? 0. So we always need to say where h is not 0. So we kind of set that in the beginning. Right? We just avoid that whole scenario. All right. So let's just put this into practice now. Let's use this. So yesterday we talked about function notation, right? We talked about it in terms of a set of directions. So for example, if I gave you f of 3 using my equation right here, what would we do? Yeah, we just put a 3 in for x, right? We'd put 3 squared minus 4 times 3 plus 7, and we'd simplify. Okay? That was a little review from yesterday. Today, we're going to do the same thing, but now we're just using our difference quotient. So notice the first thing in our difference quotient is f of x plus h. So let's find that. F of x plus h. Well, all I have to do is everywhere I see an x, I'm going to write x plus h. Okay, so all I did was everywhere I saw an x, I plugged in x plus h. Okay, we did one of these on our exit tickets yesterday. And now let's just simplify. Okay, so this first piece I'm going to have to FOIL. So I'm just going to expand it here. When we FOIL this, I get x squared plus hx plus hx plus h squared. Okay, I'm just going to FOIL this real quick. Okay, so I'm not going to bring this down yet. If you're just wondering why I'm still going down, I'm going to finish foiling this first. I can combine my two like terms here. Oh, should be an x. Okay, so that's that foiled. I can't simplify that anymore. So now I'm just going to bring down the rest. Okay. Any questions to here? All I did was FOIL. All right, so now let's get rid of these parentheses right here. Okay, so let's distribute our -4. So I have x squared plus 2hx plus h squared minus 4x minus 4h plus 7. Okay. So now look at my final equation. Can I combine or cancel anything at this point? No, okay? So this looks disgusting, right? I know you're probably sitting there thinking like, oh gosh, your head's spinning. But as we solve this, things are going to start to cancel, okay? So at this point it looks terrible, but our final answer will actually be pretty simple, okay? All right, so that's f of x plus h, okay? So we did this part. Let's do, I'm just going to write off to the side here. My f of x, remember, is x squared minus 4x plus 7. Okay, it doesn't change. It's the same thing I'm giving you. In my formula, I'm taking my f of x plus h minus f of x. So I'm going to come down here. I'm going to use a color here. I'm going to make this orange. Okay, so my f of x is going to be orange. I'm going to now subtract my f of x. So plus 7. Okay, so all I've done so far, here's my f of x plus h, that's what I just found, minus my f of x. Okay? Notice the parentheses, because we're subtracting the whole f of x, not just the x squared. Okay, so you do need parentheses around there. So let's distribute. So I have x squared plus 2hx plus h squared minus 4x minus 4h plus 7 minus x squared plus 4x minus 7. Okay? I know, it's a lot. Any questions to here? I know. This is only the numerator, remember. We still have the denominator, but the denominator is nice. What is the denominator? H. Okay, so it's just one number. We're almost there. We'll do that at the very end. Look at this problem. Am I able to eliminate anything? Yeah. Yes, this is where I can start eliminating things. Someone give me 2 things I can cross off. X squared. Okay, that's 1. The 4x and the 7. Okay, so this is a good rule of thumb. Whenever you actually do your subtraction problem, if you are not able to cancel anything out, you probably did something wrong. Okay, at this step, you should be able to cross a lot out. So what am I left with? Well, I have my 2hx, my plus h squared, and my minus 4h. Let's write that down there. Let's write in standard form, too, while we're at it. Okay. We're looking a little nicer now. Okay. Let's throw in our denominator now. This whole thing is over h. Okay, that comes from the very top in my formula. Over this h. Okay, that's where that comes from. So now we're incorporating denominator. Look at my numerator. Can I factor that at all? Yes, what can I factor that? What can I take out, Ava? I can take out an h. Okay, if I take out an h, I'm left with an h plus 2x minus 4. It's still over my h, so now what can I do? I can get rid of those h's. So my final answer is just h plus 2x minus 4. Okay? It is a lot of steps. Okay? Here's why it's a lot of steps, though, because we're dealing with all variables right now. It becomes a lot easier when we actually have numbers. Okay? In there. All right. Soak it in, digest it. Any questions for me on all this?
Are we done?
Or almost. Almost. All right. We okay? This is what you're going to practice today.
It looks a lot better than mine. Mine writes a lot better.
Okay.
I have a question.
Yeah.
When's our test?
Yes, I'm pretty sure it's Tuesday. I can double check for you though after I finish notes. But it's not till next week for sure.
Friday class even, or
Are we studying on Friday? I think we're specifically reviewing 2.4.
wait, when do we have the
Yeah.
where did the dividing by h come from?
All the way back in the beginning in my formula. See how this is what we just did, the numerator. So then at this step, I just bring back that denominator. Okay? All right. Any other questions for me on this? All right. Last page, we're going to do 2 word problems. Okay? Now, these word problems are actually pretty simple compared to the ones we've done in here. Okay? You are going to need a calculator, though. So if you don't have one, go grab one. Okay? Because we're going to use our calculator to solve these ones. All right, I'm going to read our first one here. It's about baseball. Number 1 says a baseball is hit at a point of 3 feet above the ground at a velocity of 100 feet per second and an angle of 45 degrees. The path of the baseball is given by the function f of x equals, and then I give you this guy, where x and f of x are measured in feet. Will the baseball clear a 10-foot fence located 300 feet from home plate? All right, so the equation that I give you, that's probably the most important part of this problem. Okay, I'm just going to pause and talk about what this problem means, what we're actually trying to figure out here. So our variables are a little hard to determine in terms of what they represent. Okay, if you think about my situation, let's use colors. Here we go. Here's my grass. Okay, we hit a baseball. X is always talking about the distance in length, right? So how far the ball is going. F of x is always talking about the height of the ball. Okay? So x is talking about how far the ball is going. F of x is talking about the height. Again, it kind of makes sense in my head too because f of x is y. Think of your axes, right? X is left to right, y is up and down. If that helps. So that's the problem. Okay, that's kind of what's happening in our scenario. We're asked the question, will the baseball clear a 10-foot fence located 300 feet from home plate? Okay, so in other words, there's a fence over here that's 10 feet tall. And how far away is it? 300 feet. Okay, so that's what they're asking us. They're asking us if it's going to clear that fence. They are giving us, in this problem, my x value. They're giving us that it's a 300. Okay, my x, my distance it's traveling is 300 feet. So in other words, I'm going to take my f of x equation here, and I'm going to plug in 300 for x. Okay. So we plug in 300, okay? You would type this into your calculator as you see it, okay? And then we're going to hit enter. You're going to get the answer 15 whenever you do that, okay? So my f of x is 15. So at 300 feet, the ball is 15 feet in the air. So how would we answer that question? Would it clear the fence? Yeah, because, yes, you're correct, Ian. Look at you. Because it would be, my fence is 10, it's 15, so it's going to make it over the fence. Okay, so we would say yes, the ball is 15 feet above ground. So it would clear the fence. Okay? So actually solving this problem isn't really the tricky part, right? Because we just plug our value in. The hardest part is determining what to plug in here. Okay, we've got to zoom out and figure out what's happening in my problem. Okay, that's probably the most challenging part in this one. Any questions on this word problem? Okay. All right, number 2 is where our calculator is going to come into play more here. Okay, so number 2 says the number V in thousands of alternative fueled vehicles in the U.S. increased at a linear pattern. That's important because that tells us a straight line. From 1995 to 1999. Then in 2000, the number of vehicles took a jump, and until 2006, increased in a different linear pattern. These two patterns can be approximated by the function v of t, and then I give it to you, where t represents the year with t equals 5, corresponding to 1995. Use this function to approximate the number of alternative fueled vehicles for each year from 1995 to 2006. Pause. Let's review for a second. What do we call a function that looks like this? We had a name for it yesterday. What do we call it? When I split it into two things. No, that would be a much nicer name, though. Yeah. It starts with a P. Piecewise function, okay? This is a piecewise function, okay? Why is this one a piecewise function? Can you guys find in the problem what tells me this is a piecewise function? There's a specific phrase that tells me that happens. Yeah, Justin. Until, perfect. It says it took a, right? Until, am I increasing the same thing? Even right before that, it took a jump, right? So there's a big change that happens, right? We don't know what it is. Probably something in the stock market or whatever. Always is the answer. Okay? Now, let's just define our domains here in terms of the context of my problem. So it said when t is 5, that's really 1995. Okay, so I'm just going to write 1995. So then what year would this be? Yeah, 1999. Okay? So again, all I'm doing right now is I'm just rewriting our domains in terms of our problem. So then what would this year be? What would 10 be? Yeah, no, 2000. Yeah, just because, see, we go 9 to 10. Okay? Yeah, so 2000 all the way up to 2016. Okay? So again, all we did was rewrite our domain in terms of our problem.
Would it be 2006?
Oh, yeah, sorry, 2006. Sorry. Yeah, where did I start? Use the function approximation. Yeah, it would be 2000 to 2006. Sorry. Good catch. Okay. Now, this is where a calculator is handy because what they want you to do here is they want you to tell us the number of alternative fueled vehicles, or my V, for every single year from 1995 to 2006. Okay? So, here's how I'm going to split this up. This is how at least my brain works. Okay? From 1995, so I'm just going to list all my years because this is what they want. They want all these pieces of data. All those years. Which equation am I going to use? The top or the bottom one? The top one, right? Because that fits my domain. Okay? Now, we could sit here and put them all in hand for sure, but that would not be helpful. Okay? So get out your calculator. I got my new app today. Look at that. Go in your calculator. Go into your y equals, and I want you to type in our first equation under y1 and our second equation under y2. Okay, so we've got y1 and y2 screens going on. Okay, do this with me, please. What? Good job. All right, so we type in our two equations. You're epic, this discovery.
They definitely thought you were born in like 1990.
No, Patrick did. I didn't.
1990. How old do you think I am?
19. Probably born.
19?
Okay.
Do you think I'm 19 years old? I'm honored. Oh, you're trying to guess the year?
You're born after 2000. Yeah, then duh. Oh,
Like, no, but like the
you were born in the
70s.
19s.
This is crazy.
What?
Not like 2010.
I wasn't born after 2000s.
2002.
Close. You guys are, oh my goodness, no.
2003.
No. No.
2004.
You guys going in the wrong direction. Wrong direction. There it is.
2000?
97.
1999.
Are you kidding me?
Wait, I think you said that first.
Oh, I didn't hear you. Sorry.
You gotta be kidding.
All right. Do we have our equations typed in? Okay. So now, go to your second table. Okay.
It's kind of crazy.
Second table.
She's like,
Okay. So go to our table.
Not lucky there.
You're right over there? We didn't get.
So let's go.
Okay. Okay, now in my table, I'm gonna change my screens for a second, but keep looking at your calculator. We typed our first equation right here. We typed our first equation into y1. So for all these numbers, you're looking at the y1 column. So find the number 5 in your x. Okay? So here I am in my x values, here my number 5. My y1 table, 245.7. So that's what I'm going to write for 1995. We had 245.70. Okay? All right, for 6. What do we have for 6? What does it say? 263.78. 281.86. 299.94. 318.02. Okay? You're looking at our table of values. Did you type in our two equations? These two equations.
Okay, so that's what it was.
Top one, bottom one. Okay. So these are just my first, 5 years. Okay? Now, when I do my second, when I go from 2000, 2002, 2003, 2004, 2005, and 2006. Which column are we going to look at for these ones?
Y2.
The Y2. Perfect. Okay. So now let's go to our Y2 column. And when you look at your Y2 column, you still got to make sure we're looking at the correct X values. My starting X value was a 10 in my domain. So we got to go down to the 10. Oh. And now we're looking at this guy. Oh, it's frozen. There it is. Okay, now we're looking at him. Okay, so at 10,
why are we looking at that? Why?
because we've changed our domains. So starting at 10, we now have to use this equation, which we punched into our Y2. Okay, so we had 422.4, 457.15, 491.9, 526.65, 561.4, 596.15, and 630.90. Okay, so I know. Again, the key here is to use your calculator. This would take you so long if you did all these by hand. Okay, so use your calculator to find these numbers. Okay, And then this would be your final answer. Like, I'm fine with this, okay? Don't worry about writing a sentence. If I'm asking you for a list of all the values, just list them. Don't need to write them out in a sentence, okay? All right, any questions on those two? Okay.